In this section we're going to talk about mounting holes, file generation, a thing called polygon pours, and some more rules to look at. All these things are going to help you in your final design. Let's think about our project and what we're going to do to mount this in a box, because when we're done making our project here, our printed circuit board, we need to put it in some type of enclosure. Often that means we need some way to mount it. So I'm going to show you a quick way to add holes. If I come up to my toolbars up here, there's a small little circle, it looks like a donut. If I click on it, it's going to let me place a pad. Again, I'm going to hit tab. When I hit tab, that's going to let me adjust the properties before I place it. I'm going to make the hole size 125 thousandths. That's 1/8 of an inch, so I can fit a little screw through there. The pad size I made slightly larger, and you can see you can change it. I can make the pad round, octagonal, rounded, rectangle. You can make the pad any way you want. I'm going to leave it rounded rectangle with a corner radius. And then it says net. There's no net connection, so I'm going to hook it to ground. This will be a way to have the ground on my metal enclosure connected to the ground on my PCB. So here we go, ground. I can tell it OK. Maybe I'll zoom in a little so I can see where I'm placing this. I'll put it right there. Now, when I go to place my next one, I need to hit tab again and tell it which net. I want this one also to be at ground. And I'll place it right up here. We'll come right across. Now remember, if I push this part here, you'll see some of the lines turn green. They're turning green. Altium's warning me, you're making a mistake. There's an error here or a violation. So always keep that in mind. When you see the green, you're going to want to look at it to figure out what's going on. Alright, that one I didn't place a net on. And this one I'm not going to place a net on. And why didn't I place a net? Because I want to show you we can always double click this, come back and change the net. Same on this one. I'm going to double click this one. I'm going to change the net. I've added my mounting holes. These are going to be the holes I can use to put little standoffs or studs in my box and mount it there with screws. Another thing you can do, now look down here, I have my top layer selected. There's bottom layer, top layer. If I come up here to where it says place and string and hit tab, you'll see I've put text in here that says op amp version 1.0. Right? Maybe I want my name. And it's on the top layer. I can place that right here. Now that will put copper on the top of my board with the name of the project, the version, and my name. This works if we're going to mill the boards here on campus with our laser machine, as we have no way to do this silk screen on the top. If you're going to ship your board, let's double click this and say change our layers. I want it to be top overlay. Again, I just changed my layer. Now it says op amp version 1.0 mic in the yellow silk screen that they'll print if you send it off to Advanced Circuits. I'm going to leave it copper for now, and I'm going to change the layer. Let's see, I want bottom layer. Now when I look at the bottom layer, there it is, and I'm looking right through the board. Remember, since I'm looking through the board, this text is actually going to be reversed. So I need to double click my text and tell it right here, mirror. I want to mirror that text. What happens when I mirror it? From here, it looks backwards. But if you took the board and rotated it over, it's going to be forward. So keep that in mind. If you put text on the back, it's going to have to be backwards if you're looking through the board. Let me save that. I'll zoom out to fit documents. And now we want to do another thing called a polygon pour. What that means is that polygon is a shape, and pour means we're going to pour copper on our board. And I want to do this for two reasons. The first reason is if I put copper on my board here, let me select the bottom layer. If I pour copper on my board here, I can fill all this space with copper, and I can make it a net, which I would choose ground, and that'll help with noise immunity. I'll have a ground close by everywhere that will help shield signals. So let's look on our toolbar up here under Place. Right towards the bottom, you'll see Polygon Pour. I'm going to click the Polygon Pour, and I'll get a tool. And here it says name, Polygon Pour, right? This is the bottom layer connected to ground. You can select whatever net you want. I'm going to connect mine to ground. I'm going to tell it OK. And then just like before, I'll zoom in a little to make my connection points a little easier to deal with. Right up here in the corner. So right now I'm drawing where I want my polygon pour to be. And I'm just going right along my board shape, including this notch, all the way out to the end. When I right click, it does the calculations and it pours copper on my board and covers the entire board here on the bottom with copper. Now notice where I had my text, it didn't put copper where my text was, it left it open. Notice also where I have net connections. Here's the minus 12 volts. You'll see that where the minus 12 volts is, it did not connect to the pad. Where the ground is, it did connect with the small spokes, just like we did when we had internal planes. So I've made my copper pour on the bottom. Let's do it again on the top. I'm going to go to Place, Polygon Pour, Top Layer, Ground, OK. I'll draw in my corners again. Once again, it's a little easier if I zoom in. I'm just going to roughly draw this in. Now the clearance is fairly small. The clearance between my copper pour and my components is fairly small. This clearance is going to be okay if you ship your board out to Advanced Circuits and have it made at a production facility. That'll be okay because they're going to have on the top of the board this green dielectric, which we call a solder mask. Since that dielectric is going to be on there, it will insulate where you cannot solder between this trace and this trace, because they're going to be insulated by this green dielectric. When we make the boards here on campus, we don't have that option. These traces are going to be out in the open. This is all going to be copper. So when you go to solder this little tiny surface mount part, it's very easy to get a short across here. So I'll actually want this gap to be larger. Now let's look about how we go about changing that gap. I can go to the Design and Rules. And here's my routing width. You remember changing those rules. There's also one called clearance. Here's a clearance that says 10 mil spacing between all our parts. Well, let's add a new rule. I'm going to go to clearance. I'm going to right click and say new rule. There it is. Polygon, polygon, P-O-U-R, pour, C-L-E-A-R-A-N-C-E, clearance. Advanced, and I want to call it, this advanced query is going to be capital I-N, capital P-O-L-Y, capital G-O-N, in polygon. And if it's in the polygon, we want it to be 50 thousandths. Okay, now that I've done that, what happened? My polygons have turned green. Let's go to the bottom polygon, double click it, tell it, okay, do I want to rebuild it? Yes, I do. Look at this space now. Let's go to the top polygon. Double click. Do I want to rebuild it? Yes. Now look, I have a much wider space around my parts to solder. The only place I don't have a wider space is the place where it's connected anyway, such as this ground pad is connected with these spokes. There's no use making a big space around that. This is ground. It's connected to my polygon pour with the spokes. This is not ground. I have a nice big space. So keep in mind with your design, you want to go to Rules, Clearance, right click for a new rule, name it Polygon Pour Clearance. This is where the first object matches Advanced, full query. It's in Polygon, and you want to do capital I and capital P-O-L-Y, capital G-O-N. Click OK and apply, and you'll have your rule set. Now you need to do this rule if you're making your board here on campus with a laser machine. If you're going to ship your board off, you can leave it at 10 mils. If you're going to build it here on campus, you need to change it to 50 mils so you have these nice big clearances. Look at my surface mount resistors here now and caps. I can easily solder this because I have a 50 mil clearance without shorting across here. Alright, now before we mill our boards and generate our output files, we need to look at this and find out, is this really the correct size? Do I have this thing constructed here with the proper footprints? How do I know? Well, let's go up here to File, Default Prints. Under Default Prints, I'll click it, and I'll have an option right here, PCB Prints. I'm going to check the box for Default Print and tell it Page Setup. Now by default, it's going to come up and say Fit Document on Page. And if I do a preview, here's my document. You'll see it takes my little board and expands it out to fit on the paper. That's great for your documentation and when you do your reports. But here I want to change something. I want to go back to my page setup. I'm going to tell it scaled print, and I want it 1 to 1 to 1. I want everything exact size. Here's my preview. There's my board printed actual size on the laser printer. I'll print this board out actual size, and I'll take my parts and I'll lay it on the paper and make sure they fit. I want to know that my surface mount caps are going to fit. I want to know that my B and C connector isn't going to be so big that it's going to push over here and touch my resistors or my op amps. So I print this out by paper first, place my parts on it, make sure it works, and in that way I guarantee when I get my board back all the parts will fit. I can't guarantee my circuit design is good, but I know my parts will fit. It's rough at the end of the semester when you're in a rush and you wait till the last minute and you send your board in and they print it for you and give it back to you. You put your parts on and they don't fit. And now you're at the end of the queue again and you have to submit another board. That puts you even farther behind. So use this tip. Print your board out 1 to 1 and make sure everything works. Alright, let's look at the bottom layer again. I still have my name on there with my parts. Alright, now we need to generate our files to actually have this board produced. And how do we do that? I'm going to come to File, Fabrication Outputs. We're going to have to do two types of fabrication outputs. The first one is going to be called Gerber files. I'm going to click on Gerber files, and under General, I have inches here. The units are in inches, and the format is 2 by 5. So keep that in mind. You have to make sure that these two things match when we do the second outputs. So here's inches, here's 2 by 5. I'm going to come to layers, and which layers do I want to use? Well, Altium is nice. They give me a tool here at the bottom where it says plot layers. I can tell it used on. Here's all off. No, don't generate any layers. That's useless. Here's all on. Now I'm going to generate layers I'm not even using. So let's just do used on. I've told it plot layers, whatever layer I'm actually using, turn it on. And here's the layers. And here's the extension that's going to be on your file. You'll see G, which stands for Gerber. They all start with G. And then TO, top overlay. TL, top layer. BL, bottom layer. See, so all these things are generated for us in a file. Let's tell it, okay, Altium's going to go through, do the calculations, generate those files, put them in a folder, and it generates a CAM file. A CAM file is another type of fabrication file. Let's go back to OpAmp, File, Fabrication Outputs, and we want NC drill files right here, NC drill files. I'm going to click on that, and here's where I told you to remember my units are in inches, my format is 2 by 5. If I change it and my format's different or my units are different, the two files won't line up. The holes that I generate here with the drill file won't line up with my CAM files. So I have these the same, inches 2 by 5. I tell it OK. The second little window that pops up, import drill data, tell it OK. And look, there's my 4 big mounting holes. There's my little dip 8. Here's my B and C connector holes. It's generated all my holes for me. I'm going to tell it File, Save All. It's going to ask me where to put my CAM files. I'll put it right in my design. Save. Save. I've now saved everything. And let's take a look at the files we generated. I'm going to come down here to my computer, my C drive, to Altium Designs. That's where I put my project. Here's my OpAmp project. And here's my project outputs for OpAmp. That's the one I just generated. Let's open that up. Here's what I have inside. My project name was OpAmp, and here's my CAM files, bottom layer, top layer. I have everything generated here. The one thing that you'll find out is that the drill file is called a TXT file, or a text file. Actually, all these are text files. Even though it'll say GBL, GTL, you can open it with a text editor and look at it. It's all text, and the text is describing where the holes are going to be, where the copper is going to be, the exact XY locations. So this is the folder we'll need to use when we want to generate our PCBs. Okay, thanks for watching. I hope this helps you get started with Altium. If you have any problems or questions, remember, talk to your TAs first. They can help you. They've all used Altium. If they can't answer your questions or they're not there, come and see me. I'm in the new engineering building. My room number is 239. You can come and see me almost any time, and I'll help you as much as I can. Thanks.